everyone, we're going to find the inverse of each relation and determine whether the inverse is a function. So before we start, both of these are already functions. This is a linear function. This is a quadratic function. So we have two separate problems here. So let's find the inverse. You take this linear function and switch the x's and the y's. Once you switch the x's and the y's, you have actually found the inverse. Now they want your answer in with y, so you isolate the y. So if you want, let's go ahead and let's see. I just moved the y over here, so I'm going to add y to both sides. So that gets rid of that. I'm going to subtract the x from both sides. So you get 3 minus x. That's your inverse. This is also linear. So it is a function. All right. And the next one. This is already a function. Now to find the inverse, let's switch the f of x to y, because we're going to have to switch the x's and the y's. So switch your x's and your y's. So just put the x here, the y here, and that's going to be squared. All right. Now that is your inverse. I always like to say that because it's the inverse once you switch it. Now let's add 1 to both sides. And square root both sides to solve for y. Isolate the y. That way we can put it in the calculator. Don't forget your plus and minus. So your y equals plus or minus square root of x plus 1. This is not a function. If it was just positive x plus 1, it would be a function. But we have the plus and minus. And I'm going to show you with the graph. So basically, the first one is here. This is a function. It passes the vertical line test. Now, what we got is our inverse, and I'll just put -1 here for the inverse, is going to be plus or minus square root of x plus 1. And what that is, that's a shift to the, what color do I want to use? Yellow. To the, since it's plus, it's to the left 1. And the positive part is this. But the negative part is this way. So that doesn't pass the vertical line test. You have all these x's here that have 2 y values that corresponded. It doesn't pass the vertical line test anywhere. So it's not. If you wanted it to be a function, you'd have to restrict the domain. And what you would do, and I'm going to erase this, so basically to get the inverse, what you do is you'd start with your original function and say x must be positive. So when I graph this, I only want positive values of x. So you'd only graph this part. So when you'd find the inverse, you'd only graph the upper part. And that would give you the inverse. It reflects over the y equals x axis. All right. So you have to restrict the original function to get the inverse function. But as it states, as we did the problem, we just say, no, it's not a function. Or just say not a function. And that's it. Thank you. Have a nice day. Bye-bye.